Hello, good morning. I am Seema Garg, Associate Professor in Chemistry at B.Sc Government College, Ajmer. In continuation of stereochemistry, today's lecture is on inversion, retention, and racemization of configuration in reactions. When an optically active compound undergoes a chemical reaction, three situations may arise. That is inversion, retention, and racemization. First, configuration at the chiral center is reversed. That is, inversion of configuration takes place. Walden inversion. 2-chlorobutane, when it is reacted with nucleophile, strong nucleophile, we will get 2-butanol. Here, this 2-chlorobutane having dextrorotatory configuration, optical isomer dextrorotatory. When it is reacted with nucleophile from the back side, this transition state may occur, and after leaving chloride, you will get 2-butanol, and it is levorotatory. So here, dextrorotatory starting material is after reaction, it will convert it into levorotatory in product. So this type of optical activity means this is dextrorotatory starting material, and we are getting in product levorotatory. So there is inversion of optical activity, and it is known as inversion reaction. Retention of configuration. When 2-butanol is reacted with thionyl chloride, we will get this product 2-chlorobutanol. And here, starting material 2-butanol having deconfiguration, or it is a dextrorotatory, and the product which we are getting 2-chlorobutane is also dextrorotatory. So there is no change in optical activity. So this reaction is known as retention. Racemization. In racemization, 2-chlorobutane, when it is hydrolyzed in the presence of acid, will get 2-butanol, and here we are getting mixture of dextro and levo. So it is known as racemization reaction. Suppose this 2-chlorobutane is having the dextrorotatory only, but the product which we are getting is 2-butanol is a mixture of dextro and levorotatory, and this reaction is known as racemization. See here, dextrorotatory 2-chlorobutane, and here first chloride is leaving, and we are getting carbonium ion, and this carbonium ion, when reacted with water nucleophile, means oxygen behave like a nucleophile, it may react from the back side or from the front side. So after reaction, we are getting two types of product, dextro and levo, and this enantiomer mixture is a racemic mixture, means it is plus and minus 2-butanol, and it is optically inactive. Resolution of racemic mixture of enantiomers. The process of separating individual enantiomers, that is dextro and levoisomers, from the racemic mixture is called dissolution. Such enantiomers have identical and physical and chemical properties. They cannot be separated by conventional methods of separation, for example, crystallization, fractional distillation, etc. So there are four types of methods are usually used for separation of enantiomers: mechanical method, biochemical method, chemical method, and chromatography. Mechanical method. Some enantiomers compounds form different types of crystals which can be separated by picking up similar crystals on one side and other side on other side. For example, Louis Pasteur in 1848 separated sodium ammonium tartrate by this mechanical method. He separated this dextrorotatory on one side and levorotatory crystal on the other side. So this technique is known as mechanical method. Biochemical method. In this biochemical method, we are using bio and chemical technique. Here, plus minus dextro-levorotatory racemic mixture enantiomer amino acid is reacted with acetyl chloride. Will get dextro-levo acetyl amino acid. And when this mixture DL acetyl amino acid is reacted with enzyme amylase, we will get D-acetyl amino acid and L-amino acid. So here levorotatory amino acid is separated and D-acetyl amino acid is further hydrolyzed and will get dextrorotatory amino acid. In this way, we can separate this racemic mixture of amino acid. So here we are using bio and chemical technique. So it is known as biochemical method. Similarly, tartric acid racemic mixture is separated by this penicillium. It consumes this penicillium consumes only dextrorotatory tartric acid, and levorotatory tartric acid leaves behind. So this is also a popular technique to separate dextro-levo racemic mixture. Chemical method. In chemical method, DL racemic mixture means enantiomers have identical physical properties, so cannot be separated. But DL racemic mixture, when it is reacted with salt, so we will get diastereoisomeric mixture. They have different physical properties, so they can be separated. For example, D acid plus L acid. This is a racemic mixture, enantiomer. When it is reacted with salt, D base, we will get D acid and D base plus L acid and D base. They are diastereoisomeric mixture. Or this enantiomer mixture can be reacted with L base. We will get this type of D acid L base and L acid L base diastereoisomers. These diastereoisomers have different solubilities and hence can be separated. The free acids are then obtained by hydrolysis of individual salts. So these are hydrolyzed and we will get the separate DD and LT mixture. Commonly used Kirales acids and bases are as follows: chiral acid, tartric acid, camphor, sulfonic acid, etc. Chiral bases are morphine, quinine, etc. Next and last method is chromatography method. By chromatography method, we can separate enantiomers, optical isomers, because they have different RF values. Usually HPLC, high performance liquid chromatography, is used for separating enantiomers dextro and levo, and it is very modern technique to separate enantiomers. Thank you very much for today's lecture.